Okay, so this is just some practice to help you practice using these dots from Lewis dot structures to draw the chemical bonds. So if we look at this one, we have calcium and we have chlorine. So calcium is here and chlorine is here. So we have a metal and a nonmetal. That's going to be an ionic bond. So, and remember, ionic bonds, we have a giving and a taking of electrons. So the one that's going to be giving is calcium, and the one that's going to be taking is our chlorine. And we also know this from the oxidation number, because remember, here chlorine has an oxidation number of -1, so we know it's going to be gaining an electron, and electrons are negative. And our calcium has an oxidation number of +2, so it's going to be giving those electrons away. So it has an overall positive charge because it has more protons than electrons. So we can use those two numbers, or we can just use our dots like we have here. So we can have our calcium, and then that one electron is going to leave and go over to our chlorine. So that chlorine now has an overall charge of minus. And our calcium now, it still has this one electron left, but it has an overall positive charge. And so for this, we don't draw a bond like we do for covalent bonds with a line because it's not sharing those electrons. Instead, we have these electrostatic bonds because we have magnetic forces from our positive and our negative, just like magnets. So here our opposites are attracting, causing this bond to form. This is how we would draw this bond. We'd also have our another chlorine with 7, and then it could also take this electron over here. So that we have an overall negative charge on this chlorine as well. Because this overall, we're going to have it be CaCl2. Will be the name of this one. Okay, so let's try the next one. We have lithium and fluorine. So fluorine is here, lithium is here. So we have an oxidation, say, of +1 and of -1. So we can also do our swap and drop. So we can write the oxidation number up here as the charge. We have our +1 and our -1. And then when we swap and drop those, this one is actually pretty straightforward because they're both 1. So we have LiF. And so here we're showing that we have this 1 electron lithium coming over here to make our fluorine have 8 electrons. So our lithium is going to have an overall positive charge, and our fluorine is going to have an overall negative charge. Okay, so for this next one, we have calcium. Calcium here and oxygen. So oxygen has a -2, calcium has a +2. Oxidation state, so we'll put those over here. Oops. I was trying to get that little cursor thing to go away, but it didn't work. So here if we do our swap and drop, we have the 2 calcium on the calcium coming over to the oxygen and the other way around. And remember again that we have to simplify it. So we're not going to write Ca2O2. Instead, we're going to simplify that to just CaO. So we have these 2 electrons here coming over to fill in those spots on the oxygen. So we have the calcium. Now this calcium, it's losing 2 electrons, so overall it will have a +2 charge, and our oxygen is going to have all 8 electrons, and it's going to have a on. Here are some more examples where we have calcium and chlorine. So calcium plus 2, chlorine minus 1. And so that's going to make calcium chloride with CaCl2. Our sodium is here. Sulfur here is going to have minus 2. So we have plus 1 and minus 2. So this time when we switch this, it's going to have our 2 come over to our sodium, so Na2S. Just some more practice. Okay, so the only other thing we haven't talked about is the properties of our ionic and our covalent compounds. So this will go in your notes, just some different properties of these two types of compounds. So our state at room temperature is that our ionic compounds are going to be crystalline solids. They're going to be solids that make crystals. And this is pretty easy to think of because like our basic example of an ionic compound to think of is NaCl, or salt. And we know that salt is a solid and it's also a crystal if you look at it really small under a microscope or even just look at it, and especially those sea salt, those large chunks, you can see that they are crystalline. So our covalent compounds, on the other hand, they aren't going to be crystalline, but they're going to have liquid, gas, and solid. They can be lots of different states at room temperature. Okay, so our melting point, this is the temperature at which it is going to melt. So our ionic compounds have a high melting point, and our covalent compounds are going to have a low melting point. So again, you can think about our sodium chloride example, and a covalent compound that is pretty easy to think about is water. So in comparison to the temperature it's going to melt at, water is going to melt at a lower temperature than salt, which salt will take a very high temperature in order for it to melt. Okay, so electrical conductivity as a liquid. So our ionic compounds are going to conduct electricity, while our covalent compounds are going to not. And the reason of this is because in order for electricity to be conducted, an important thing which we'll talk about a lot more next semester is that it needs charges, especially our electrons. So since our ionic compounds, we have one positive thing and one negative thing, because we have our electrons being taken from one thing over to the other side, and we have those two distinct charges, we're actually going to have to make it able to conduct electricity. But our covalent compounds, since they're sharing those electrons aren't able to then participate in helping pass electrical currents. Okay, so then another characteristic is solubility in waters. This is looking at the ability for it to dissolve in water. So again, we can think about salt, and our salt is able to dissolve in water, so it has a high solubility. And covalent compounds, on the other hand, are going to have a low solubility. And then our last thing, conducts electricity when dissolved in water, and this is a similar property as before. The difference between these two is that the second one is when it is dissolved in water, the water with the compound dissolved in it is conducting electricity, as opposed to just the compound by itself. And here we still have the same trend where yes, it's going to conduct electricity, and it's not going to for our covalent compounds. Okay, so you have a worksheet that you can work on to practice these. We're actually, I think I told you guys before that we were going to have a quiz. We're going to push that quiz till next week. So we'll have that quiz on Tuesday, and that's going to be over our ionic and covalent bonds. So naming of those and identifying the chemical formula of those, as well as there'll be some questions on nuclear energy and half-life. And I'll have, so you guys can work on the worksheets to help you study for that and practice these problems. So I'll see you guys next week.